Today we are going to talk about some formulas that are called our sum and difference formulas. Sum means adding and difference means subtracting. So these formulas are going to tell us how to add and subtract angles inside of trig. Now, of course, again, PowerPoint hates when I do parentheses and formulas. But what these formulas are doing is taking, for example, this first one says sine of u plus v. And it tells us what that is. Now, it's a common student tendency to kind of want to distribute that sign through and say that it's sine of u plus sine of v. That'd be really nice if that worked, but it doesn't work. Because distributing is something we do when we're multiplying. And we're not doing like sine times a u plus v. This is a sine taken of two angles that are being added together. And so then we end up with these formulas that will allow us to evaluate these. You do not need to memorize any of these formulas. So in the first lesson on 14.3, there was all of our identities. They said you didn't need to memorize those. I'll give them to you at the test. I will also give you this list of identities on that same formula sheet for the test. So you don't need to worry about memorizing any of these. And they're pretty messy, so you probably won't have them memorized, and that is fine. I usually have these problems memorized for about 2 weeks every year, and it's like when I'm teaching it that I do it enough times during the day that they'll like stick back in, but then in about a month from now, if you ask me, I'm not going to remember them anymore. They're just not that important to remember all of them. So what we're going to be doing is looking for an exact value. So that means we don't want to just plug this in the calculator. We could plug cosine 75 in the calculator. It's going to give us some big messy decimal. But we want our exact answer, the perfectly precise answer, which means that it will likely have some square roots in it. And we're trying to find it here for 75 degrees. So our first step is to find two angles. And it can only be two, not more than two, because our formulas just allow for u plus v. Not like w plus x plus y plus z. And we can't add a lot of stuff, just two things. So we want to think of two angles that we know that we can add or subtract to get 75. So what are two angles that we've worked a lot with that we could add or subtract that make 75? 45 and 30 add up to 70, and those are angles that we've worked a lot with. Those are special angles because they exist in the triangles. So we're trying to look for like 30s or 60s or 45s that we could use to add. We can also use our unit circle values. 0, we wouldn't really want to use 0 because that doesn't change anything, but we could also use 90 or 180 or 270 if that would help us out because we can evaluate all of those. So our first step is find two angles we could add or subtract that'll give us the number in the problem. The second step is to then plug this into the formula. So since we're adding, we're going to look under the sum formulas and we're going to look for cosine. So the cosine formula under adding says cosine u, cosine v. uv just means first thing, second thing, minus sine u, sine v. So under the sum formulas, I look up the cosine one, and it tells me to do the cosine of each of them minus the sine of each of them. The order of the 45 and the 30 doesn't matter. So like I did 45 plus 30. If you did 30 plus 45, we would end up at exactly the same place. So step 1, find two angles we could add or subtract to get the angle that we want. Step 2, plug it into the formula. Step 3, figure out what each of these things is according to our special triangles. So for the 45, we need our 45, 45, 90 triangle. Cosine is adjacent over hypotenuse. So that gives us 1 over square root of 2. For the 30, I need the 30, 60, 90 triangle. Cosine is adjacent over hypotenuse, so I get square root of 3 over 2. Sine of 45 is opposite over hypotenuse in the 45 triangle. And sine of 30 is opposite over hypotenuse in the 30, 60, 90 triangle. Okay. Step 1, find two angles we can add or subtract to get the number we want. Step 2, plug it into the formula. Step 3, figure out what each of those things are from our special triangles. And then the last step is to just clean this up with some arithmetic. we are going to begin by smushing these fractions together, multiplying together the tops and the bottoms. Okay, when you multiply fractions, you just multiply together the tops and multiply together the bottoms. When you do that, you should always end up having a common denominator. If you don't, you've done something wrong.
So if it's like cosine 45, you refer to the 45, 45, 90 triangle?
Yep.
Oh.
And then the adjacent or hypotenuse. Yep. So once you do your multiplication, smush them together, they should always have the same denominators. If they don't, you did something wrong. And that is very handy because to add and subtract fractions, we need that common denominator. And you will always have it already. We're going to leave our answer right here with a square root in the denominator. The back of the book does not. So if you check your answer in the back of the book, this is not what their answer will say. If you want to still know whether or not your answer is right, what you could do is plug the answer that you got into your calculator and it's going to give you an ugly decimal. Then plug the answer they got into the calculator and it should give you the same ugly decimal. And that's okay with me to check your answers that way. If you do plug this into the calculator to check it, just be careful. You're going to need to actually put some parentheses around that denominator when you plug it in. But that's an okay way to check your answers if you want, because the back of the book is going to take it a step beyond what we're doing.
When you choose the 45 and 30, do you have to pick an angle from each triangle? Or can they be from the same?
They could be from the same triangle. It's not likely, though, because either way that would just give us 90, and 90 we could already kind of work with. So.
Can you go over simplifying it again?
Once we have the four fractions, how we simplify it. When we multiply fractions, we multiply together the tops and then multiply together the bottoms. So 1 times square root of 3 is just square root of 3. 2 times square root of 2, just 2 square root of 2. So, and then they'll always end up having the same bottom. So then we can just put both of the numerators over the one denominator. All right, we have 3 more examples of this kind of problem. So if you're feeling a little uncomfortable, we've got some more practice we can do on this. In our second one here, though, our angle is given in radians. So the first thing I would suggest doing is converting this into degrees. We could work in radians if we want, but then we're adding and subtracting fractions, and they have different denominators and common denominators, and I think it's just a whole lot easier if we just convert this. So to convert, we learned that we're going to put the same thing we're given onto the bottom. We always use 180 in pi because 180 is equal to pi. So the pi's cancel, and I do 180 divided by 12, and this thing turns into then the tangent of 15. Okay. So if you're given a problem in radians, I suggest that as your first step, you go ahead and change it to degrees by multiplying by 180 over pi. So then we're looking for 2 angles that we could either add or subtract that will give us 15. So what could we do?
30 and 45.
30 and 45. So we're doing a subtraction, so that's a difference. So we're going to look under the difference formulas, and then we're doing tangent. So we look down to that very last formula, and it says tangent u. U means first thing, so that's tangent 45 minus tangent 30 over 1 plus tangent 45 tangent 30. And then we need to evaluate these things. So from our 45, 90. Oops. And our 30, 60, 90. Tangent of 45 is opposite over adjacent, so that's 1 over 1, or just 1. Tangent of 30 is opposite over adjacent, so 1 over square root of 3. On the bottom, I get 1 plus tangent of 45, which is 1, and tangent of 30, which is 1 over square root of 3. I am okay with leaving square roots in a denominator, but I am not okay with leaving fractions of fractions. So we have one more step we need to do to simplify this. When you end up with fractions of fractions, to simplify it, we are going to multiply the top and the bottom, both by whatever I call the mini denominator. The denominator of the little fractions inside of there, we're going to multiply by that denominator. Why is it okay that I just multiplied by square root of 3 on both the top and bottom? Because I'm really multiplying by square root of 3 over square root of 3, which is just 1, right? So since I'm multiplying by the same thing on the top of the fraction as the bottom of the fraction, I'm really just multiplying by 1. So then we're going to distribute on the top. That gives me square root of 3 minus 1. And distribute on the bottom. That gives me square root of 3 plus 1.
Where did the square root of 3 come from?
I'm choosing to multiply that by that because that's the denominator of the little fractions inside of there. So it will get rid of the little fractions then.
How come you didn't multiply it by the 1 and then the 1 because it's 2 1s?
Because this 1 times a square root of 3 is really just the 1 over square root of 3. Because we're multiplying there as opposed to the adding. When you distribute, you have to multiply it to everything that's being added. But this 1 times, really 1 times something is just itself, so I could just as well erase that little 1 that's multiplied there. There is another set of angles that we could have chosen that would have given us 45 that actually would have turned this problem to be a little bit quicker. So what other angles could we subtract that would still give us 15? 60 minus 45 would also give us 15, and it turns out that this is a little bit quicker. I like doing that other one, and even if you guys would have come up with this one first, I still would have shown you this other one, because you can't tell from the get-go which one is going to be easier or harder, and you do need to know how to clean up that situation that happened in the last one. But just to show you what would have happened if we did this one, so it's still the tangent subtraction formula. You don't have to write this down if you don't want to, because it's going to turn out exactly the same. But then I'm going to do tangent of 60, and tangent of 60 is opposite over adjacent square root of 3 over 1, or just square root of 3. Tangent of 45 is 1. 1 plus. Tangent of 60 is square root of 3 over 1. And tangent of 45 is 1, so times 1, except it doesn't really matter if you're multiplying by 1. And we get the answer right there off of just one step instead. So it turns out that actually works out a little bit better. But from the beginning of a problem, you can't tell which way is going to be the better way. So you just kind of pick the set that you see. And if you end up having those little mini fractions in there, just multiply by their denominators. Questions? All right, I'm not sure if your notes say sine or tangent here, but we're going to do sine for this third example. My notes actually say tangent, but we're going to do sine because we already did tangent of 15 in the last problem. You could. It wouldn't give us new practice, though. So for 15, we learned that we have 2 different ways to do it. For sine and cosine, it turns out it doesn't really matter which one you do. Okay. Tangent's the only one that there might be an easier and harder one because the tangent formula is a fraction. So that's how we would end up with those fractions inside of fractions. For sine and cosine, it just really doesn't matter which set you choose. So this is a subtraction. So we look under the difference formulas for sine. And it says that it is sine of u cosine of v minus cosine of u sine of v. So that each angle gets the sine and each angle gets the cosine. And then we are going to evaluate these from our special triangles. So sine of 45, opposite over hypotenuse, is 1 over square root of 2. Cosine of 30, adjacent over hypotenuse, is square root of 3 over 2. Cosine of 45, adjacent over hypotenuse, is 1 over square root of 2. And sine of 30, opposite over hypotenuse, is 1 over 2. So then we smush together the fractions, multiply together the tops, and multiply together the bottoms. And you should always have a common denominator. So then you just put the numerators together over that denominator. This is exactly the same answer as question number 1. There's really only so many possible answers you can get for these because we're using square roots of 3's, 2 square roots of 2's, and 1's. So there's only so many combinations of those that are going to work out in these problems. So don't be surprised if you start seeing kind of the same numbers over and over. Questions? Okay, this is our last example of this type, and it's a radians example. So as a first step for solving with radians, I would say multiply by 180 over pi to turn this thing into degrees. So then we do 7 times 180 divided by 12. You can feel free to use calculators for that. You don't need to do that arithmetic in your head. And it turns out to be cosine of 105. And at this point, I'm going to let you go ahead and try to work this problem through from here. Okay, so what two angles can I add or subtract to get 105? I can add 60 and 45. All right, so then we're adding, so we're going to look under the sum formulas, and we're using cosine. So we look for the cosine one. It says to do the cosine of each minus the sine of each. It doesn't matter whether you did 60 plus 45 or 45 plus 60. It'll all turn out the same in the end. So then we use our special triangles. 30, 60, 90. And 45, 45, 90. Cosine adjacent over hypotenuse for the 60 is 1/2. For the 45 is 1 over square root of 2. Sine of 60 opposite over hypotenuse is square root of 3 over 2. And sine of 45 is 1 over square root of 2. We multiply these together. That denominator should always be the same, so we can just put them together over that denominator. We end up with almost the same answer as the last one, except that 1 and square root of 3 are backwards of each other, so it's actually the opposite answer as the last one. But again, we end up with a lot of the same numbers coming up in our answers, so don't be surprised when they all start to kind of look alike. Right. Questions? All right, we didn't, in any of these examples, use our unit circle, but be aware you can use your unit circle for stuff as well. So you could use the numbers 90, 180, and 270 to be able to add or subtract things from as well. So if I was looking to do the angle, and you could use our special angles within those. So let's look up a problem here. If your angle ends in a 5, you know you're going to have to use a 45, right? Because that's our only angle that ends in a 5 is the 45. So if, for example, I wanted to work with the angle 195, okay? Well, I have to use a 45 because that's the only way to get a 5 onto the end of that. So what's left over there?
1
150. That doesn't seem like a special angle. But if we graph 150, where does it end up? 30 before the 180. So we do end up getting a special triangle then. So we can still work that out using the 45 and the 150. Okay? If your angle ends in a 5, you know you're going to have to do 45. So then figure out what other number works with it. And it may be a special triangle that's kind of flipped somewhere within one of the quadrants. Okay? All right, that's our first type of problem. Our second type of problem, it says, find the sine of u minus v. Given that, and then it gives us some information. First thing we're going to do is write out our formula, sine of u minus v. So sine of u minus v, I'm just going to look up that exact formula and write it out. Then we're given some information about the angles u and v.
Excuse this interruption. Nick Buwalda and Natalie Lyons, please go to the cafeteria. There is a silver Volkswagen Beetle in the student parking lot that has its lights on.
All right, so for angle u, we are told that it is between pi, which is 180, and 3 pi over 2, which is 270. So angle u is somewhere down in here. We are told its sine, opposite over hypotenuse, is negative 3/5. You did problems just like this in 14.3. This was our first 14.3 night assignment, and that's why this was the assignment there, is because now we're doing that same thing here, and then it's within the context of a problem, so we're going to build from it. We need to find that other missing side, which we can do with the Pythagorean theorem, or that 3, 4, 5 is kind of a special triangle for us. It's a negative 4 because it's a left 4. Then we're going to draw a triangle for V. V is between 0 and pi halves, which is 90. So V is somewhere in that quadrant. Its cosine adjacent over hypotenuse is 12 over 13. And we can use Pythagorean theorem to find the missing side there. Now what we want to do is evaluate this problem using those two pictures. So when it says the letter U, I'm going to look at the U triangle. So sine of U, I look at the U triangle, and opposite over hypotenuse is negative 3/5. And later on in the formula it says cosine of U is negative 4/5. When it says V, I look at the V triangle. Cosine of V is 12 over 13. Sine of V is 5 over 13. There may be some arithmetic that we could do to simplify these fractions at this point, but don't. Okay, don't simplify them at this point. Just multiply together the tops. So I get negative 36 over 65. And for the second part, we have minus and negative, so it's going to turn to plus 20 over 65. Again, don't reduce, even if they can reduce. These can both reduce here, but don't do it, because at this point they have common denominators, and they always should. If you've done the problem right, they will have common denominators. So we want to add them together and make it negative 16 over 65. If that reduces, reduce it, because that's our final answer, but this one doesn't reduce. Questions? Okay, with that, I'm going to stop here for today. We have a few more examples that we will do for this lesson tomorrow. So your homework won't be due tomorrow, but if you are interested in getting a start on it, this 19 to 26 is the first type of problem that we looked at. So we've done all of our examples on that type of problem. And then this 31 through 33 is the one that we just looked at that one example for. We're going to do one more example of that kind of problem tomorrow, and then we'll do the type of example that covers those last three. So you could definitely do those first four problems with what our examples did today. Those middle three, maybe not, depending on how comfortable you were with that last example.